Okay, now I'm going to move on to this question whereby you want to find the differential of 2 cos pi x plus 1 cube plus 4 tan cube x over 2 plus pi by 3. Now I'm going to differentiate one part here and add to the differential of the second part. So in doing so, what I'll do is I'll focus on this first. I'll bring out 2 from the differential since it's a scalar multiple. Take note that the cube is with regards to pi x plus 1 and not cos pi x plus 1. But for the second part of the differential, the cube here is with regards to tangent x over 2 plus pi by 3. Okay, so it can be expressed this way. Now I'm going to move on to differentiate both sides of the expression. So in order to differentiate this, it is quite similar to this form whereby you differentiate cosine fx. So we start off with the differential of fx. Differential of fx will give us 3 pi x plus 1 squared. Okay. And after that we have to change this into minus sine pi x plus 1. Okay, so this is the first portion. Next part, let's differentiate this portion. So we will have plus 4. Okay, next, let's differentiate tangent x over 2 plus pi by 3. So that means we bring down the 3. Tangent x over 2 plus pi by 3. And now we have to differentiate the inside. When we differentiate the inside, we will end up with secant square x over 2 plus pi over 3, and differentiate this x over 2. X over 2, when we differentiate, we end up with a half. Okay, and at this point, let's simplify. Simplify this portion. You could bring out the negative sign, negative 6. Coefficient will consist of pi x plus 1 squared sine pi x plus 1. Okay, so that's the first portion. And the second portion, let's look at the coefficient. We have 4, 3, half. So that makes 6. 6. Okay, then let's simplify this portion. Tangent. Now, since the square is the square of the entire Trigo expression, I'm going to put the square inside. X over 2 plus pi by 3. Okay, multiplied by secant square x over 2 plus pi by 3. So this will be my answer for the last example. Now moving on, let's take a look at this, whereby given that y is cos x over 5 plus sine x, find the value of dy dx when x is 0.5 radian, giving your answer to 3 dp. Let's not concern ourselves with what x is first, but we find dy dx. Because if we sub x equals to 0.5, we do not have any more x in the equation. How are we going to find dy dx, right? So let's find dy dx first. And if we were to look at the equation, it's in the form of a fraction. So let's use the quotient rule. quotient rule, we put down the denominator, we differentiate the numerator, minus numerator, and we differentiate the denominator. Okay, and divide by the square of the denominator. Okay. At this point we can simplify. So let's simplify by multiplying everything out. So we have if we were to extract out the negative sign from the numerator, we will have this. Okay, and if you notice this sine square x plus cos square x is an identity. It's a Trigo identity that adds up to be 1. So we could simplify this portion here. Minus 5 sine x plus 1 over 5 plus sine x whole square. So that's our answer, okay, for dy dx. And now we can bring in the value of dy dx when x is 0.5 radian. So let's sub in when x equals to 0.5 radian. So when it's in radian, calculator mode has to be switched to radian. Okay, do the relevant inputting of the numbers, and you will end up with minus 0.11314. And this can be rounded off to 3 dp, minus 0.113. So that's the answer.